I'm Thales. You'll be starting now talking about supply chain attack and prevention. I will do the introduction. So, what is supply chain? Supply chain is the network of people, companies, processes, and tools required to produce and deliver a product. It's about all the steps that you need to do something. So, here is an example. We have some raw materials that that go to a supplier, will be processed, distributed, and then go to the customer. So, an example we can use is like the about the car manufacturers. We have the materials that will be produced again, and it will be assembled to make the car, and then to go to the market to some people to buy it. And each step depends on the previous, and if anything falls here while the process will stop it or will be damaged or something. And how does this apply to the IT? We need to think that also at the IT industry, we depends on other service or libraries or anything that it's made by others. For example, if you use Java, we have some Java libraries that you use, or some open source projects, or even like service, for example, Microsoft or the cloud, like Azure, etc. So if any of those have some bugs, something that anyone can exploit it, everyone that use those information will be affected. So yeah, what's I doing? So key points to remember. Supply chain is all about dependence. It's all like a chain. Everything it's linked. And when something it's exploited, it's damaged, everything that depends on it will be affected too. And now I will pass to Maria to say about identifying risks.
Hi everyone, I'm Maria. I've been working in Sulzer for about almost a year as a developer. So yeah, now that Thales explained to us what are supply chain attacks, I'm going to explain, we're going to learn how to identify these attacks and what are the risks of these attacks. To identify them, I think we should also know how the attackers do it. And to start, I want to emphasize on dependencies and third-party softwares. So the first thing we have to ask ourselves is, why are dependencies risky? So first of all, dependencies can be incredibly useful. They save us time, save us development time, and let us benefit from code others have already written. But this can also have some drawbacks. First, dependencies introduce a reliance on external code that we didn't write ourselves. So we are placing trust in someone else's code. And this can be kind of, uncertain. External code might contain known vulnerabilities like CVEs. CVE is a standardized system for identifying and cataloging publicly cybersecurity vulnerabilities. These common vulnerabilities and exposures can lead us to security issues if left unpatched. So, what kind of another risk can lead because of this introduction of external code? So another one could be hijacking, when the attackers manage to take control of the library of the application. Also, dependencies reduce our ability to fully comprehend the code our application relies on. So we're kind of losing control. But just to summarize, dependencies aren't bad. They serve as like an important purpose. They can, as I said before, they save us time, but there is like opening a door to supply chain attacks. So we must be very careful. So how exactly does vulnerabilities sneak into our dependencies? Now let's dive to the common attack vectors. Attackers often prey on the complexities of dependency management and even developing habits to exploit vulnerabilities. So the first common way they do it would be dependency confusion attacks. By doing these attacks, the intruders exploit the way package managers like npm and PyPI resolve dependencies. So these malicious actors upload packages to public repositories with the same name as one of our private internet packages. How do they do it? So let's explain the exploitation process. First of all, as I said, the attacker begins identifying internal packages. How do it? They do it by analyzing publicly available documentation or source code repositories. So it's very important that we didn't public important code to the public. And these attackers examine dependency files such package.json because that's where the information is. So once the attackers find these files, they upload public packages with the same name as the private ones, but with a higher version. That's because package managers often prioritize like a better match, like a secure match. And that's why they choose higher versions. So we developers, if for example run npm install, we might be fetching malicious packages instead of our private ones. So as I said, these attacks are very effective because of how package manager works. And yeah, first let's continue. And as we are going to see of the ways attackers take control of our dependencies, we're seeing that every attack is based on insertion of malicious code. Malicious actors can exploit dependencies to introduce harmful functionality into the application, and this can be achieved through different types of techniques. The first one being typo squatting. This can be quite similar to the first example of attack I've explained, but the difference is that these are package, like the attacker uploads package names with similar names as popular libraries. So for example, if we want to use the dependency requests, sometimes we misspell it, we can write it like this. So the intruders, they take advantage of this and they create libraries like this one. So if we misspell as I said, at a configuration file, at the dependencies file, we can mistakenly download these files. So another technique would be obfuscation, where attackers disguise code to make it difficult to understand or detect. So they can blend this malicious code software with legitimate processes and files. So these kind of techniques can range from simple to very complex, including code minification, where compressing code into an unreadable format. They can also use encryption when encoding portions of the code, only decrypting them at runtime. So yeah, we kind of see some unreadable lines and we didn't know what these lines do. And another type of obfuscation will be code that behaves differently across staging, production, and local setups. So maybe the malicious code is on the deployment. So we must be careful with that. These type of harmful activities could lead us to, as you know, ransomwares, data theft, also cryptojacking. So yeah, we must be careful with that. Another attack would be outdated dependencies. With developers, often when we create an application, we integrate up-to-date dependencies. But usually it's kind of difficult to maintain, to keep updated. So over time, vulnerabilities are discovered in these older versions, leaving the project exposed. What type of vulnerabilities can we see in these outdated dependencies? We can see SQL injection, where attackers send malicious database queries, or cross-site scripting. And related to these updated dependencies, we also have transitive dependency risks. As we can see in this image, sometimes we are using dependencies in our project that depends on additional dependencies, that relies on additional dependencies. So maybe our project is up to date, the dependencies we want to use, but if those dependencies maybe are using some older versions, so then there could be hidden vulnerabilities that we don't know. And as we can see in this study from OpenSSF, 65% of vulnerabilities are found in transitive dependencies, in those dependency trees. And yeah, it looks like, as it looks, it's kind of difficult to see this kind of risks. And yeah, maybe when we realize it is too late. So this kind of attacks, this kind of risks are very difficult to, yeah, as I said, realize we have it in our code. And now let's touch on the lack of publisher authentication. Many package managers doesn't verify the identity of the publisher. So maybe if we are going to download a library, we don't know if it comes from a legitimate person. So yeah, it can lead us to what we're seeing, to some vulnerabilities. And to finish these examples, the last one will be unreviewed CI/CD pipelines. Many organizations use continuous integration and continuous deployment pipelines to fetch, build, test. But sometimes these pipelines aren't properly secured. So without realizing, we can pull dependencies from untrusted sources, as we said before, or execute unverified code. So yeah, now that we understand the common ways vulnerabilities creep in, Sujit is going to explain to us how can we prevent these supply chain attacks.
Thanks, Maria. Hi, everyone. My name is Sujit Ami. I am a Java developer in Sulzer, Espana. So, as my colleagues Thales and Maria explained about supply chain attack and uh, how can we identify the supply chain attack, I would like to explain more on how can we prevent the supply chain attack. So, let's start with the supply chain attack impacts. So, there are many types of attack impacts of supply chain attacks. Now, first one we'll discuss the operational disruption. So when attacker attacks on the system, the critical service may be shut down. If attacker targets the supply chain software or the hardware component, there might be a delayed in a delivery that can interrupt the production line or logistic in industries like manufacturing and retail. So this is one of the main impact. And the second one is the data breaches. Data breaches. In data breaches, attacker can steal the sensitive customer data and secrets of the data by through the compromisation to the third party connections. A third one is regulationary damage. Regulationary damage means reputational damage. Reputational damage means a customer can the attackers can damage the reputation of the organization, uh, through which a customer may lose the confidence in the organization ability to safeguard their data and operation, and also damage the brand image. And the last one is financial losses. In financial losses, there might be the two type of losses: direct cost and indirect cost. Indirect cost are the expenses related to the incident response, system recovery, and payment if ransomware is involved, and also the legal fees. And in indirect cost, a loss of business opportunity, cancellation of contract, and revenue drop caused by the operational downtime. So these are the impact which happens when supply chain attack happens. Now we can discuss about the steps involved in supply chain attack. There are four steps we can discuss. The first one is reconciliation. So reconciliation is the first stage of attacks in which attacker research and identify the weak point in a supply chain to target. Their objective is to locate the vulnerable third-party vendors, contractors, or the software provider connected to the primary target. The second step is weaponization. Weaponization is also called as initial compromise. In this step, the attacker infiltrate the systems or infrastructures of the identified third-party vendors or the supplier. Third step is delivery. Delivery is also called as a propagation to the primary target. So once the vendor or supplier is compromised, attacker use it as a delivery mechanism to infiltrate the primary target or its downstream partner. And the last stage is exploitation. This is the last stage where attacker try to compromise the primary target. So after successfully delivering the malicious payload, attacker exploit the vulnerability in the target system to establish the foothold and maintenance persistence. For example, deploying a remote access Trojan to control a system, maybe using the backdoors or malicious script to escalate the privileges, etc. So these are the ways or the steps involved in which attacker used to do the supply chain attack. Now we can discuss the prevention which we can use to prevent the supply chain attack. The first one is zero trust architecture. In these steps, the organization can restrict the access to critical system and ensure the continual verification, and also enforce the least privileges principle across the supply chain. The organization can provide the least privileges access to the user and also restrict the access to the critical systems. The second type for a prevention is third party risk management. So, third party risk management means uh, you can regulate the security assessment and audit regularly. For example, ISO 27001 or SOC2. So these types of audit can uh, regulate through the third-party vendors or suppliers for their security practices. The third point we can discuss is endpoint monitoring. Endpoint monitoring is especially used for the detection of endpoint visibility and also mitigation of the attacks. You can use the tool Endpoint Detection and Response (EDR) for real-time monitoring and mitigation of the APIs, and also network segmentation to limit the spread of the attack. The fourth one is the incident response planning. These plannings are used by cybersecurity teams where they can prepare for the breach with a clear response of the plan in a collaboration with the supply chain partner, and also they can conduct a regular tabletop exercise and simulation to handle the incident very smartly. Now we will discuss about one of the real-time example which happened in the real-time world, the RV tool supply chain attack. So RV tool, first of all, the RV tool is used to RV tool is used for the installation of the VMware. So the hack up this hack was actually discovered after the security research revealed on the infected version of the installer downloaded from the website, and the malware the loader which was called as Bumblebee malware. So to minimize these kind of attacks uh, from the core packages, you must know that what software you are using, leverage of software composition analysis, and software bill of material to the inventory your third-party software use. For sensitive project, you can consider introducing the quarantine of package that are not immediately needed. The packages should still be reasonably up to the date so you can receive the security fix, but integration can often be delayed by a few days. Secure development culture. As we discussed, to mitigate or prevent the supply chain attack, first of all, you need to maintain a secure development culture. The modern software development depends on the open source libraries, APIs, and CI/CD pipelines. But these dependencies are very vulnerable. For example, the unverified dependencies can lead to the wide scale of attacks. So, for example, the attacks which we already discussed, the RV2 supply chain attacks. And one more example, we can say the Log4j vulnerability exploited in the Java libraries, because the Log4j framework is open source. So, attacker tries to compromise the Log4j framework so that they can primarily attacks to the application. So, you must always use the secure development culture by using the automation tools and also the JWT tokens, bearer tokens, etc. Next, we can discuss on preventing the supply chain attacks. The first step is ship left security. Uh, to use this ship left security, you can integrate the security early in your software development lifecycle, SDLC. You can use the automated scanning tool during the coding process so that you can handle the dependencies smartly, especially the open source dependencies. And second thing is adopt secure coding practices. You can also you can also train your developer on secure coding practices like OWASP top 10, and you can also perform the regular peer coding review. And the third point is regular penetrating testing. Penetrating testing means the Cybersecurity team simulate the mock attacks on your development environment to check whether your application is smart enough to handle the this kind of attacks. And also they'll try to do the remedy for these kind of attacks happens in a real world. And fourth one is the use of software bill of material SBOM. By using this tool, you can maintain the transparency and track a dependency, and also identify and patch the vulnerability in open source management. So this tool is very useful when you're using open source dependencies and also the APIs, etc. Now we will see what are the tools you can use to detect and monitor the supply chain attacks. The first one is MS Defender. MS Defender is a kind of antivirus and anti-malware solution. Is integrated into the Windows and protect the computer from the virus, spyware, and ransomware. It's a real-time protection component and it is praised for its solid protection. And it will help to detect the uh, attacks on your endpoint and response. And the second tool is CrowdStrike. It's a American cybersecurity technology company provide the cloud native platform called CrowdStrike Falcon, which offers endpoint security, threat intelligence, and cyber attack response service to stop the breaches for the business. So these two tools are used for endpoint detection and response. Similarly, you can see the two tools, MS Sentinel and Splunk, which is used for incident and event management, security information and event management, SIEM. And MS Sentinel, SOAR, and CrowdStrike Falcon, these two tools are examples for security orchestration, automation, and response. By using these tools, you can automate the scripts to handle and monitor the attacks happens in your application. For the threat intelligence and platform, you can use recorded future and normally threat stream tools. So these are the tools which is used for detection and monitoring the supply chain attacks. So usually the organization cybersecurity team use these kind of tools for prevention of the supply chain attacks. So yeah, now I would like to conclude our webinar. Uh, I can summarize the things what we have discussed from the starting to now. We discussed about what are the supply chain attacks, how we can identify the supply chain attacks and risks, and how can we prevent and what are the impact of supply chain attack, and how can we prevent by using a secure development culture, and finally the tools which can use to detection and monitoring for the supply chain attacks. So thank you everyone for joining this session, and I hope the knowledge which we have shared will be very useful for you in your development and working activity. Thank you everyone. Thank you. Have a nice day.